Hi everyone, welcome to the video for 1.2. So today we are learning about different characteristics of graphs. So basically all of these things, I would say most of them, these first four probably, we should know from algebra 1 and algebra 2. And I'm sorry if you're already tired of me saying that. But we're going to go back over them now a little bit and then learn a few new things. Okay, so all I did to fold this was I folded this on that line to fold that over, and then I folded this over for the title. You can cut the little tab, or the dotted lines to make little tabs to see the stuff underneath, but you don't have to. That's why I made this to like hold them down if you do cut them. Okay, so that's it. Let's start learning about different things. So we talked about domain and range in the first lesson. But since it's so important, we put it back on here again. So the domain of the function is its corresponding x values, where the function can exist, and the range is the corresponding y values. Intercepts we've done for a long time. So the x is when it crosses the x-axis, and the point would be at that x number and 0. And for y-intercepts, it's always 0 for x, and then you'll have your y value. So they switch where the zeros are. So x-axis, x-intercept is 0 for y. Y-intercept is 0 for x. So for your zeros, roots, and solutions and x-intercepts all mean the same thing. It's basically when your graph crosses the x-axis, but sometimes we call them what its zeros are, because that's when y is 0, what the roots of the equation or function are, or what the solution to the equation is. But all of those things mean the same thing. It's when y is 0. So that's the important part of that. Okay? So y being 0 is what's important about all those things. But we just need to remember 0, roots, solutions, x-intercepts are all the same thing. Okay? Okay, so our asymptotes, I wanted to include this since we're talking about all the different things of graphs, but a lot of this stuff that we're talking about for like as far as the examples and stuff, we're not going to get into asymptotes yet, but I wanted our list of things about graphs to be complete. Okay, so asymptotes are lines that the graph can approach but never intersect. And asymptotes can be horizontal, vertical, or slanted. I think you've had exposure to that before, but we're going to get to it when we do graph trig functions and when we graph some other functions in chapter 2. Well, in this chapter, actually. Okay, so next we have increasing or decreasing intervals. So all this means is when is the graph increasing or going up, when is it going down, and it can also stay constant if it's a horizontal line. Okay, so as you go to the right, so as your x value increases, as you're moving to the right, what's happening to your y value? Is it going up, or is it going down, or is it staying the same? Okay, and it's just like you would think. So the function's increasing if the y value is going up. So if your graph is going up, if it has a positive slope, it's increasing. If it switches and goes down, it's decreasing because the y value is decreasing. And if it doesn't change at all, it would be a constant. Next, we have our relative max and min. So what this is the relative max is like the highest point in that region. It could be the absolute max if it's the highest point out of the whole graph. Relative min is the lowest point in that particular region, or it could be the absolute minimum if it's the lowest point of the whole graph. Okay, and some graphs don't have absolute ones, and I didn't put those definitions on here, but like I said, it's if the graph doesn't get any lower. Like a parabola would have an absolute min or max, where other graphs, like a cubic function, could just have a relative one because it goes forever. Okay, and then the last one is even or odd functions, and what those are is it talks about like if it's symmetric. So if it can be mirrored or symmetric to the y-axis, it's even. So it means it's like reflecting over y equals 0. So like a parabola y equals x squared would be an even function because it's reflected over the y-axis. Odd functions are symmetric to the origin. So it actually reflects over y equals negative x, so that would be like the slanted line here, which y equals x to the third is an odd function. So sometimes if you just look at the graph, you can tell But sometimes they'll just give you an equation, and then we can use this idea. So these points, xy and negative xy, would have to be part of the function to be even. And xy, negative x, negative y would have to be part of the function to be odd. And we're going to practice some of those and look at even or odd. Okay? Okay, so let's look at our examples that are right next to those definitions. Okay, so we're going to take this graph and analyze it and go through all these different things about it. Okay? So, does the graph represent a function? Well, we can use a vertical line test that we kind of talked about in 1.1 to determine that. Is there any of those x values that happen more than once? Can we draw a vertical line through it and touch the graph more than once? No, we cannot. So that means that the graph is a function. Yes, the graph's a function. So our domain, remember, that represents our x values. So where do the x values in this graph exist? So if I'm moving from left to right, the first time I hit my graph is right there at -5. But if I keep moving to the right, I'm never not going to hit a piece of my graph because there's an arrow here and it's going to go forever. So my graph starts at -5 and then it goes on to infinity. So that was the interval notation we talked about last class. So does a point exist at -5? It does, so that's why I use the bracket, because it exists there. It's there. But since it's going forever, I can't include that, so you use a parenthesis. Okay, so for our range, we start the bottom. Am I touching my graph? Not until I hit this point right here. So I'm going to start at -1, and since there's a point there, it's going to be a bracket. And as I'm moving up, I'm still touching, and since I have an arrow pointing forever, it's going to keep going forever, so it's going to go to infinity. So for number 3, it says to find f of 1, f of -2, and f of -10. So we're just analyzing the graph to find the values. So remember, this is when does x equal, what do we get for y when x is 1, is what this means. So if I go over to x equals 1, I can find my y value. So f of 1 equals 5. Go ahead and try to figure out the other two. So f of -2 equals 8. And f of -10, if we go over here, there's none of our graph is ever here, so it doesn't exist. So DNE does not exist. That's not a point on our graph. Okay, so this says for what value of x, so we're looking for x numbers, is our function, our graph, less than 0. So remember, another thing for here is y. So when is our y value less than 0? So what x numbers makes our y less than 0? So remember, y is equal to 0 here. So when is it less than 0? Well, that would be between here and here. So that just that little tiny bit, it's below 0. Okay? So if we look on the left side, what's that x value here? -5. So we know that on the left side, we'd have -5. And then on the right side, I know you can't tell exactly how it is, but if we count the slope, our slope is rise 3, run 1. Okay, so this is a third of the line, or a third of the space. So then that means if this is -4, we'd go over 2/3 to get to there. So that would be -4 and 2/3. So -4 and 2/3. So it says less than 0, not equal to 0. So at -4 and 2/3, it's hitting that 0 mark. So I'm going to put a parenthesis. So our x values between -5 and -4 and 2/3 is when we're less than 0. And we could have written it as an inequality. -5 x, -4 and 2/3. If you didn't understand where I got the 2/3, make sure you circle it, and we'll talk more about it in class. Okay. Okay, so x-intercepts. So that's when does y. So for our x is when y equals 0, and for our y is when x equals 0. So our x one we just talked about is this point right here, which was at -4 and 2/3. Our y would be here at 3, so it's 0, 3. Very good. So increasing and decreasing. So when are we increasing? So we have a positive slope on this part of the graph, right? So what are our x values? Because we're writing our interval in terms of the x. So we start at -5 and I go all the way to -2. So we have from -5 to -2. Is there any more increasing parts of our graph? Well, when we hit here, we're going back up, and then we keep going on forever, right? So from 0 to forever, we're going up. So we would say that we also have union, which is just another way of saying and, 0 to positive infinity. So those are the spots that our graph is increasing. Is there any constant spots on our graph? Very good, there's not. There's no horizontal lines. So decreasing, when is our graph going down? So we're going up from here to here. It's just this piece that's going down, this part of the parabola that's there. So from -2 to 0. So we're decreasing from -2 to 0. Okay, almost done. So is the graph even, odd, or neither? So is it mirrored over the y-axis? Or is it flipping like over this line? So does it flip from here to here? Neither of those are true. So it's not any of those, it's neither. What are the max and min, the relative max and min? Okay, so this is where we're going to kind of talk about absolute max and min too, because it has an absolute minimum. Is there a lowest point on the graph and the graph will never go below it? Yes, right here. So we have an absolute minimum. But is there another low point? Yep, this one. So this is the relative minimum and this is the absolute minimum. Okay, so relative min would be that point right here at 0, 3. And then the absolute min is that other point down here where the graph doesn't get any lower. So absolute is the graph will never get any lower. So like the vertex of a parabola. And that point is at -5, -1. So the lowest point of our graph is -1. So as far as the minimum, since our graph is going up forever, there's no absolute minimum because it goes to infinity. But we have a relative, I'm sorry, I meant maximum. There's no absolute maximum. Okay, but we have a relative maximum with this point here. Because out of the rest of the graph, in this section, that's the highest point we get. Okay, so our relative max is at -2.8. Awesome job. Let's look at our examples on the back. Okay. So for 1 through 4, we're just using this equation to try to find these things. Okay. So I think that we should be okay with most of this. So I want you to try it on your own. Remember what it means for f of x. F of x is y. So this is saying if y is 2, what do we get for x? If x is 2, what's the function or y? And then is this point on the graph? So we would just plug those in for x and y and see what happens. And then x-intercepts, remember that means when y is 0. So I want you to try those 4 questions and I will explain them after you try them, and then we'll do the bottom ones together. So sometimes I write it like this so I don't have to actually do the fraction, but this means x plus 1 is on the top and x plus 2 is on the bottom. So it would be like x plus 1 over x plus 2. Okay? So y, or f of x, equals that fraction. So go ahead and pause your video and try those 4 examples real quick, please. Okay, so here we go. Okay, so x and y, I plugged in y and then the x values, and I got 1/2 equals 2/3. So that's not a point on the function, or on the graph. Okay? If x equals 2, we get 3/2, so the point would be 2 3/2. If y equals 2, we get, you have to cross multiply. Put it over 1 and cross multiply. You get x is -3, so there's our point. If y equals 0, we get this. I cross multiplied to get this, so x is -1. So the x-intercept would be -1, 0. Okay? So let's do the bottom and we'll be done. So, for the picture, sometimes you can just tell, like I was saying, if it flips over this line, it's odd. If it flips over this line, it's even. And if it does neither of those, it's neither. Okay? So remember the other thing was that the odd functions had xy, negative x, negative y. Xy, negative x, y is even. So we have this point here that's 1, 1. And then I have a point here on the graph that's negative 1, negative 1. So that is the definition of an odd function. Okay, so for this one, I have this point. So I have 1, negative 1.5, and then I have 1, negative 1, negative 1.5. So the y values stay the same, the x values flip. So this is going to be even. But another way is just it flips over the y-axis. Okay. So if they don't give you a graph, the way to tell is by plugging in an x number and then plugging in the negative version of it and seeing what you get out for the y numbers. Okay? Because if I have x and negative x for even, the y should be exactly the same. But for odd, if I have those, the y should be opposite. Okay? So I always just do 1, you know, because that's the easiest. So if I plug in 1, I'd have 1 squared minus 5, so that'd be negative 4. If I plug in negative 1, negative 1 squared is 1, so 1 minus 5 is negative 4. So when my x values become opposite, the y values stayed the same. So is that even, odd, or neither? Good, it's even. This equation is almost just like this. This equation would be y equals negative, or let's do the x squared first. X squared minus 2.5. So, I mean, it's just moving the y-intercept a little bit. So it's like the same. Okay, so for this one, I'm going to plug in 1 again because that's the easiest. And then I'll plug in negative 1, and we'll analyze what happens to the y values. So if I plug in 1, 1 to the third minus 1 is 0. Negative 1 to the third would be negative 1. Negative 1 minus 1 is negative 2. So did they stay the same sign or become opposite signs? They didn't even say the same number. So that tells us this graph is neither. Okay? Okay, so why don't you guys try 9 and 10 and see what happens with those ones. So I would, again, plug in 1 and negative 1, okay? Okay, so plugging in 1 and negative 1, I got that these are opposite, so that means it's odd. And here I got them the same, so it's even. And that is it. Remember, write down any questions you guys have, and we'll make sure we talk about them in class. I mean, you got to ask in class, but we'll go over anything you guys didn't understand before we work on our practice, okay? Okay, that's it. Werner out.